Welcome students. Welcome to Maths Tutorial Lakshya channel. Here we have our next topic, mole concept. So what is mole? Mole represent the amount of substance that contains same number of particles as number of atoms in 12 gram of carbon. That is equal to the Avogadro number 6.022 into 10 to the power 23. So basically it is a unit to measure amount of substance. So 1 mole of atoms equal to 6.022 10 to the power 23 atoms. Similarly, 1 mole of molecules equal to 6.022 into 10 to the power 23. So, basically, 1 mole atoms equal to this Avogadro number of atoms equal to gram atomic mass in case of atoms. While in case of molecules, it is gram molecular mass. So, remember this. It should be used in our numericals, coming numericals. So, mass of 1 mole of substance equal to molar mass. Generally, we say molar mass or atomic weight or molecular weight. Volume of 1 mole of substance equal to molar volume. We have some formulae that we should remember for solving our problems. Now, number of moles. It is the basic formula in mole concept. What is number of moles? So, number of moles equal to mass of element upon atomic mass, or you can remind it as a mass upon molar mass. Now, mass of one atom. In case we have to calculate mass of one atom. So, atomic mass divided by Avogadro number, that is 6.022 into 10 to the power 23. So, it is the formula for mass of one atom. Now comes moles of compound. Similarly, mass upon molar mass, but mass of compound divided by molecular mass. In this case, we will take compound and molecular mass. Now, mass of one molecule, like the mass of one atom, similar formula. Molecular mass divided by 6.022 into 10 to the power 23. Now comes volume. Volume occupied by 1 mole of gas at NTP. This is normal temperature and pressure, that is 22.4 liter, or we can say 22400 ml in case of CGS unit. So here are some formulas. Now we will apply these formulas on our problems and we'll check how the solution came. So first question is the very common questions. Calculate the mass of one atom of C14, carbon 14. So mass of 1 mole of carbon equal to 14 gram. We know that. What do we know that? The mass of 1 mole of carbon. It is not for the one atom of carbon. It is for the 1 mole of carbon. So what is 1 mole? It is not a one atom. It is 6.022 into 10 to the power 23 atoms of carbon. So what is the mass of 6.022 into 10 to the power 23 atoms? It is 14 gram. So it is 14 gram. Now mass of 1 mole equal to this, and mass of 1 mole. What is 1 mole? This is 6.022 into 10 to the power 23 atoms. It comes 14. Now using the unitary method, mass of 6.022 into 10 to the power 23 atom this. So mass of 1. So it comes in the denominator. 14 upon 6.022 into 10 to the power 23. That comes out to be 0.00232 into 10 to the power minus 20. Now here many students have difficulty in solving this, where we should put the decimal on the left, on the right, or why we should uh, put the decimal. So here is a rule of the physics and chemistry, we can say basically science. If we move the decimal right, 10 to the power goes, if we move the decimal left, 10 to the power goes added, and if we goes toward right, it goes minus, subtracted. So here, and always the decimal comes after one number. So here is the 0.00232. So decimal must come after one number, that is 2.32. So to make 2.32, we have to move the decimal toward right. Okay, so we have to subtract. Okay, remember this. So count in between 1, 2, 3. So we will subtract 3. This comes out to be 2.32 into 10 to the power minus 20 minus 3. Finally, 2.32 into 10 to the power minus 23 gram. So this is the answer of one atom of carbon 14 mass. Now 100 molecular sucrose. So we should remember the formula of sucrose, the sugar C12H22O11. Mass of 1 mole of sucrose. We will calculate it mass C12H22O11. It comes out to be 12 into 12 plus 22 into 1 plus uh, 11 into 16. That comes out to be, after solving, 342 gram. So what is 1 mole? This is 1 mole. 6.022 into 2123 molecules. If we are dealing with the molecules for compound, and in case of element we will write the atoms. So this is 342, and using the unitary method, for 1 it goes in the denominator, and the final answer is 5.67 into 10 to the power 20 gram. So it is for 1 molecule, but we have to calculate for 100 molecules. Now using again the unitary method, if we have 1 and we have to count for many, we will multiply. So this is into 100, and we got a final answer 5.67 into 10 to the power 22 gram. Now comes, calculate the mass of an atom of silver. So we have to calculate one atom mass. Similar of the first question. Mass of 6.022 into 10 to the 23 atoms of silver. This is 1 mole. This is 1 mole. What we know, that 108 gram, that is the atomic mass. So using the unitary method, we have to calculate lesser number, so it goes in the denominator. If we have calculate for more number, it goes in the multiplication. If we have to calculate for less, it goes into the denominator. So it goes into the denominator. This is, and after calculating, we got the answer 1.79 into 10 to the power minus 22 gram. Now comes the next question. Calculate the number of molecules and numbers of atoms present in 11.2 liter of oxygen at NTP. So here we have to calculate the number of molecules and numbers of atoms in 11.2 liter oxygen. So what we know, number of molecules in 22.4 liter of oxygen. In the formula section, when we are calculating the when we are writing the formulas, so we have told that 1 mole equal to 22.4 liter of whatever the gas or liquid. So number of molecules in 22.4 liter is equal to the Avogadro number, that is the 1 mole. This is the molar, 1 mole. So similarly we have to calculate for 11.2. So using the similar unitary method, we will calculate for 1 liter. So this value 22.4 goes into the denominator. Okay, so if and now we have to calculate for more, not for 1. So we will skip one step and do it right here. 11.2 liter, and it goes in the multiplication. So this will goes into the denominator, and this will goes into the numerator in the multiplication. After solving, we got the answer 3.011 into 10 to the power 23 molecules. So this is the value of 11.2 liter in the number of molecules in 11.2 liter. So now comes 1 molecule of O2 equal to 2 atom of O, because there is O2. This is the 2 atoms of oxygen. Now we have to calculate the number of atoms. There are two questions in the question. Number of molecules. We have to calculate the number of molecules, but we have also calculate number of atoms. So number of atoms equal to twice the number of molecules. So 2 into, what we have the answer, 3.011 into 10 to the power 23 atom, that is 6.022 into 10 to the power 23 atom. This is the final. So we have this answer 1 and this answer 2. So this is the answers of the question, number of molecules as well as the number of atoms. Now 1 molecule of N2 equal to how many, mass, we have to calculate mass. 1 molecule of N2. So what we know, that 1 mole of N2 equal to 28. How? N2 equal to 14, the mass of nitrogen 14 into 2. This is 28 grams. This is the molecular mass. So 1 mole equal to molecular mass, that is 28 gram. Now what is 1 mole? 6.022 into 10 to the power 23. So it is 28 gram. Now we have to calculate for 1. We have to calculate for less. So it goes into the denominator. After calculating this, we got the answer 0.00465. So using the earlier technique, we will put the decimal 1, 2, 3 places toward right. though we will subtract minus 3. So the answer is 4.65 into 10 to the power minus 20 minus 3, that is minus 23 gram. The final answer is 4.65 into 10 to the power minus 23 gram. Now comes the mass of 1 molecule of water. This is a very important question. Mass of 1 mole. What we know? Mass of 1 mole. Because we know the atomic masses and the molecular masses. Water H2O. This is 2 into 1 plus 16. That comes out to be 18 grams. So the molecular mass is 18 gram. What is 1 mole? 6.022 into 10 to the power 23 molecule. This is 18 gram. Or we can say 1 molecule. This is denominator, it goes in the denominator, 18 upon 6.022 into 10 to the power 23. The final answer is 2.98 into 10 to the power minus 23. Now the next question. Calculate the number of moles in following. 7.85 gram of iron. Here is some info for you all. Centigram. For the word centi, we use 10 to the power minus 2. For milli, we use 10 to the power minus 3. Pico, 10 to the power minus 12. Nano, 10 to the power minus 9. Micro, 10 to the power minus 6. So these are certain terms that we should know because it is often asked in questions. So if we don't know about this, so that we cannot calculate the question. So remember these terms: centi, milli, pico, nano, micro. Now comes this question: number of moles. We can solve this. We have solved in the earlier question, in the earlier problem we have solved by the unitary method, but we have also the formulas. But sometimes students seems to forget the formulas or don't know how to apply this. So for them, or I can say for all of us, the unitary method is best because it is the best method to solve any of the question, not for moles, most of the questions in chemistry. So that's why I have used that method, but I will show you both methods in these questions. So 7.85 gram of carbon, we have to calculate the number of moles. First of all, in this question we have iron, silicon, carbon. The mass of atomic mass of iron is 56U and silicon 28U, and the carbon we know very well, this is 12U. So the number of moles, we have used the formula number of moles, mass upon molar mass, mass of the element and upon molar mass. This is 7.85 in the question. 7.85 divided by 56. 56 is the atomic mass of iron. So that comes out to be 0.14 moles. So this is by using the formula. But if you forget the formula, if you don't know how to apply the formula, which formula in which question, so you can use this. What we know, the moles and the molar mass, 56 gram Fe is equal to 1 mole. So what we have to calculate should be in the right, and what is given should be in the left. So we have to calculate the moles. The moles in the right. 56 gram Fe equal to 1 mole. 1 gram Fe equal to 1 upon 56 moles. Now 7.85 gram equal to, we have to calculate 1. Next we have to calculate for moles. So it goes into a multiplication. So it comes out to be 0.14 moles. This is the simple unitary method, or you can use the formula, whatever you like. But this method according to me is more reliable. Now comes 4.68 mg of silicon. This is number of moles. The mass is 4.68 and this is milligram. And you know that 1 milligram is equal to 10 to the power minus 3 gram. I have told you earlier. So this is 4.68 into 10 to the power minus 3 divided by 28. Solving, we got the answer 0.167 into 10 to the power minus 3. So we have to put the decimal 1 toward the right. So 1.67 into 10 to the power minus 3 minus 1, that is minus 4 moles. Now 65.6 mu g of carbon, that is microgram. So you know that mu g is equal to 10 to the power minus 6 gram. So applying this, 65.6 into 10 to the power minus 6 divided by molar mass, that is carbon 12. So after calculating, we got the answer 5.467 into 10 to the power minus 6 moles. You can also solve these questions through unitary method. That is basically up to you. The mass of 94 point, we have next question. The mass of 94.5 ml of gas at STP, this is standard temperature pressure, is found to be 0.2231 gram. Calculate its molecular mass. So what we have given is the mass of 94.5 ml. This is the volume, this is the mass, and we have to calculate its molecular mass, the molecular mass of the gas. So first of all, we will use the formula of density, where we have connected mass and volume. So density equal to mass upon volume. This is 0.2231 and this is 94.5, and after solving we got the density 2.36 into 10 to the power minus 3 gram per ml. This is the CGS. Now, density is also the molar mass upon molar volume. We have used this only the masses, and now comes the molar mass and the molar volume. So we will use this. Density is the constant, density doesn't change. So we will put this value in the density, and the molar mass, we have to calculate the molecular mass, and the molar volume we know very well, that is the 22.4 at STP. So after solving, it goes into the multiplication. After solving, it comes 52.86 gram, or we can say 52.9. We can also say the 53 gram, whatever, but the exact answer is 52.86 gram. So in this question, we have used the formula of density. First of all, the normal mass and normal volume, then molar mass and molar volume, because density remains constant. We have used this fact. Now comes the next question. Calculate the number of molecules in a drop of water weighing 0.05 gram. So we have to calculate the number of molecules. So we have the number of molecules, and we have given mass 0.05 gram. So basically, what we know in every question, what we know the molecular moles, we know the moles and the molecular atomic mass. So in this case, we have water, we have molecule, so we will use the molecular mass. We have to calculate number of molecules, so it should be in the right. What we have to calculate should be in the RHS. So 18 gram equal to Avogadro number of molecules. This is the mole, 1 mole. Now for 1 gram, it goes into the denominator. Now for 0.05 gram, it goes into the multiplication. After solving, we got the answer 1.673 into 10 to the power 21 molecules. So basically, what we know should be in the first line, and accordingly we do the next steps. So 18 gram this, 1 gram this, and 0.05 should be in the multiplication. Now comes the next question. This question is very important, because especially the B and C parts. Look, in the first part, we have to calculate 52 moles of argon, number of atoms in 52 moles of argon. In second and third, there is 52 U and 52 gram. So I will tell you the difference between the U and G, that is micron, and the second is the gram. Next, so first question, calculate the number of atoms. So what we know, number of atoms. So number of atoms should be in the right. 1 mole argon equal to Avogadro number 6.022 into 10 to the power 23 atoms. So 52 mole equal to this number into 52. That comes out to be 3.13 into 10 to the power 25 atoms. So this is likely the unitary method. In the next question, that is for helium. The atomic mass of helium is 4 gram. In this case, first of all, we should know the difference between U and G. What is U and what is G? U, that is AMU, which we write shortly U. It is actually AMU, that is atomic mass unit, and G is the basically that is the grams. So what is the difference between U and G? U is unified atomic mass, AMU. It is the standard unit for expressing mass on atomic or molecular scale, while G, that is gram, on the other hand, is simply the molecular mass expressed in grams. So accordingly, we will do the question. So in the first case, we have 4u of helium. That is 4u. This is the mass of an atomic or molecular scale. So this is 4u is equal to the 1 atom, not the Avogadro number of atoms. Remember this. That's why these two questions are very important, because they are giving us an insight of a concept, u and g. So 4u equal to 1 atom, 1u equal to 1 upon 4, 52u equal to 52 upon 4. That comes out to be 13 atoms. On the other hand, for 4 gram of helium equal to not 1. It is Avogadro because it is gram. So a gram is the molecular mass. So it is the moles. 6.022 into 10 to the power 23 atoms. So 1 gram equal to 4 comes into the denominator. Now 52 gram, it goes into the numerator, multiplication. So after solving, we got the answer 7.82 into 10 to the power 24 atoms. Now comes this next question. Calculate the number of atoms of each type in 5.3 gram of Na2CO3, that is sodium carbonate. First of all, we will calculate the molecular mass. This is 23 into 2, 23 for sodium, plus 12 for carbon, 16 for oxygen. This comes out to be 106 gram. Now we have to calculate atoms of each type. So we have 3 atoms: sodium, carbon, oxygen. So we have to calculate number of atoms. The question is number of atoms of Na, C and O. In first case, 106 gram. We have to we know that molecular mass equal to the moles. So we have 106 gram. First of all, remember in the question, we have Na2CO3. So what we have given? We have 2 mole Na, 1 mole carbon and 3 mole oxygen. Remember this. So using this, 106 gram Na2CO3 2 into, because 2 mole Na. In the formula we have 2 mole Na. So 2 is this and mole is this. So 2 into this. So 106 gram this, 1 gram this, and 5.3 grams. It goes into the multiplication. It is already in the denominator. And after solving, we got 6.022 into 10 to the power 22 Na atoms. Similarly, in case of carbon, 106 gram, this is moles. For 1 gram, it goes into the denominator. And for we have 1 mole. So this is 5.3 gram goes into the multiplication. After solving, we got 3.011 into 10 to the power 22 atoms of carbon. For oxygen, we have 3 moles. So 106 gram equal to 3 moles. 3 into 6.022 into 10 to the power into 10 to the power 23. 6.022 into 10 to the power 23 oxygen atoms. For 1 gram, it goes into the denominator. For 5.3, it goes into the numerator. After solving, 9.03 into 10 to the power 22 atoms of oxygen. So this is for oxygen. So Na2 mole, 1 mole carbon, O for 3 moles. So using this from the standard formula, we have calculated this. Or remember one thing, 1 mole equal to 6.022 into 10 to the power 23. Whatever atoms, molecules, or we can say particles. That can be electrons or ions. So this is this is all about the mole concept. What is mole? How to calculate mole? I have told you 2 methods: the formula method and the unitary method. Thank you. I hope you like the video. Please subscribe the channel Maths Tutor Lakshajit and help us to grow more. And for more videos, stay connected.